Welcome to Tutor Justin, and that's me, your everyday tutor who just has a good enthusiastic for AI technology. ChatGPT, Gemini, and all these other AI tools are very fascinating when it comes to just the educational space. I've been tutoring for 12 years now, 13 years. I paid my way through grad school. I paid my way through undergrad by tutoring. So I've been a part of this educational realm for a long time. And guess what? This is a game changer. This is something that I think can replace a big portion of the tutors like me. And I've had to embrace it. I'm all right with it. If I can't beat them, join them. And in this series here, we're going to see how ChatGPT here specifically, how it can help solve and help teach derivatives. How good is it? What can it do? What can it do? What are the limitations? We're going to go through. This is a part 2 of a 3-part series on derivatives. We're going to look specifically at the chain rule. We're going to talk about logs, exponential functions, how can it recognize, how can it check your work, can it provide practice problems, what can it really do to help you learn these derivative rules and how to use them. One thing that I've really enjoyed so far about this series is just the wide ranges of tools that ChatGPT can do. It's not perfect, by all means, but you have to remember, neither is going to your professor, neither is having a friend or a tutor. Sometimes they make mistakes. Your parent, who's ever helping you with your work, they're not always perfect, and getting them to understand certain things on where you're struggling can be difficult sometimes. This ChatGPT isn't the best, I believe, for starting from scratch. But if you need a refresher course, I know sometimes I took a calculus class like 3 years ago, right? 3 years prior, and then all of a sudden you have to do derivatives again. I need a quick refresher on how to do it. Boom. You can prompt it to give you practice problems. What are the rules again? How do you use them? And go from there and get your refresher done in an hour, right? So it's a time saver for that aspect. We'll talk about how can it help with homework. Homework is something that you need to get 100% on. That's why it's only 10 to 20% of your grade. You need to do well on it. You also need to do well on it so you understand the material. So when the test comes around, you can ace it. Why do you want to get an A on the test? Well, to do well. Just so you know that you can do certain things, do well in class, do well in school, so you can hopefully get a better job. But these small things on taking pride in your work and taking pride in your class goes a long way, and you can that really translates to how good of a job you can get, how successful you'll be. So it's not just about getting A's and B's, it's about the process, and if you understand and willing to put in the work on the process, be way beneficial for you in the long run. I don't think at all this is cheating. A lot of these professors actually think ChatGPT is just a way to cheat. Even some of these students, they don't like to know. They don't like to tell people, yeah, I use it all the time. Yeah, I use it to check my work. Yeah, checking your work is a great way of actually knowing if you're doing it correctly or not. Don't use it as a crutch, but use it as a tool to study. Use it as a tool to make sure you're on the right track, because nothing's worse than thinking you got the entire process down. You turn in your homework and you get a D on it because you messed up on half of. I'm all on step 4, right? I never did step 4 right. I didn't do step 4 correctly in any of the homework. Well, this is a way to make sure you're doing it well. And those that cheat are the same ones that would plagiarize. I don't really see a statistical difference in the number of people that actually cheat, because if you're going to do it one way, if you're going to cheat before ChatGPT, you'll cheat after, and there's not that many people that have added. It's a tool, again, a tool to make sure you're doing it right, to tool to make sure you're learning it correctly. It's a tool to help you, not replace a professor. Nothing replaces going to class. I firmly believe nothing will replace the professor. It can't talk to you. It can't even write an XY plan. It can't even draw a plan. It doesn't do very good illustrations. It's just starting to do tables and showing how everything lines up when you're solving for X, when you're doing our system of equations. It did a good job. When it was talking about when we were dividing rational exponents and doing synthetic division, it finally lined up all of our coefficients correctly. So you can check out that video, and it's a cool way, and we'll see how well it does on this part 2 on this derivative series. So let's get this thing started. Okay, everybody, as you can see here, this is a derivatives worksheet or a problem set. We only have about 3 different derivatives that we're going to talk about. We can have something with chain rule, something with logs, and E with some with a function over there in the power. So these are, a lot more advanced in the first series or first part of this derivative test. Just want to see how ChatGPT can handle these. And I know that this is a little bit outdated, as in we don't get problem set like this anymore. We don't. Majority of you guys get them online through Pearson, some type of cafe, Blackboard, Canvas. There are various amounts of online platforms that professors or universities use for math. I don't necessarily agree with them because most of them are multiple choice or fill in. You don't really get to see the steps. That's why I like ChatGPT, because if you can work through the steps, it shows you the steps. You can upload, as you'll see. I'll upload some of these files or some of these I worked some of them out, and let's see how well it does at checking my answers. But this is a great tool for homework, as we previously stated. So practice problems here. Let's just get started. So I've uploaded the document, and this is wild. I used the Math GPT. In previous videos, I know I've used Tutor Me, I've used Math AI, I've used regular Chat GPT 3.5. That's the non-paid one. The Chat GPT 4.0, the paid version. I wanted to try this. This one's pretty interesting. Every time you upload a document or something, it doesn't give this. Each GPT gives a different, really, first step. For example, this one went through the entire thing. Problem 1, problem 2, problem 3, what to do. And then they went ahead and just did it, which is very, very interesting. Let's kind of go back and forth here. First, let's ask it to explain the chain rule. So I know the first one is the chain rule, and then we have logs at E. So can you please go over how to do the chain rule, the rules for natural logs and E's? What I like to do is explain it to me like I'm a high school student. Thank you. I always say please and thank you, always, because you never know what happens. If AI takes over, I watch way too many movies. Hopefully they know you said you were nice to them. That's all I gotta say. The hard part about some of these rules is trying to remember them. And I know that math people can, if you're not a math person and you're just taking the class, and they use a lot of notation that you're unfamiliar with, or g of x equals this, and the derivative of, so we're going to set u of x equal to x squared, and then we're going to take the derivative, and it all can just be messy. So let's see, that's why I asked him, teach it to me like I'm a high school student, which is cool. Let's see how good it does. Imagine you're a fast food chain and there are 2 steps to get your meal. First, you order your food at the counter, and then you pick it up at the window. Each step is dependent on the previous one. No order, no food to pick up. Okay, interesting. The chain rule in calculus is somewhat similar. It's used when you have functions within functions, like a Russian doll. When you have to take the derivative of such a function, you start from the outer layer and work your way in, taking derivatives as you go and multiplying them together. Okay, that's cool. Here's a simple formula for the chain rule. Okay, so dy dx is where you're trying to find the derivative of y with respect to x. Good. It says respect to x, dy dx, so it shows that the denominator is what you're taking a derivative with respect to. Example, if y equals 5x plus 3 squared, and we set u equal to 5x plus 3, then y equals u squared. To find the derivative of y with respect to x, we find the inside. Okay. Let's start with the chain rule. Can you please go into detail on how to use it with an example? So let's just go with the chain rule. Because as you can see, do you see how there are, it says like the slash and then fraction dy, those are like latex coding that should make it look like it's the math sign of dy dx, dy over dx equals like the math terms, and it looks like it kind of messed up, which isn't good. So let's see if it changed it. Of course, let's deep dive into the chain rule with an example that will help you grasp how to apply it step by step. Think of the chain rule as the key to unlocking the derivative of a function that's nested within another function. It's like uncovering layers to find the core. Okay, so there are multiple layers here. We probably have to start with the outside 4, and then the derivative of the inside. Here we have a function that's raised to the 4th power, but that function itself is more complex than just x. To tackle this, we must break down using the chain rule. Identifying the outer and layer functions. Outer and inner functions, okay. The outer function is something to the 4th power, u to the 4th. If we had just u to the 4th, we'd know how to differentiate it, right? The inner function, this is what we're substituting in place of x in the outer function. Differentiate the outer function with respect to u. We treat u as a variable for a moment, so if our outer function is u to the 4th, its derivative is normally 4u to the 3rd. Differentiate the inner function with respect to x. Boom. Just a derivative of the inside. Apply the chain rule, and now we multiply them. Substitute what we've got. Perfect. And u to the 3rd is always just the inside. Substitute back in the inner function. And there you have it. We've used the chain rule to find the derivative of a complex function by peeling away its layers, treating it as its composition of 2 simpler functions and working our way through them systematically. This method helps manage even the most tangled functions by breaking them into digestible parts, like dismantling a puzzle, solving it piece by piece. Okay, so to break it down, I kind of like it to the derivative of the outside times the middle times the derivative of the middle, right? So it is derivative of the outside times the middle times the derivative of the inside. Exactly. You got it. Your summary captures the essence of the chain rule perfectly. It's about taking the derivative of the outer layer, it's called the outside, keeping the inner function as it is the middle, and then multiplying the derivative of the inner function. Here's a breakdown again and the way you've summarized it. So it took what I said and really summarized it in a way that made it very simple to follow what they said, which a lot of it, that's what learning is. You gotta, it's taking what the teacher says and what you said and kind of combining it. Every time you take notes, like whenever I tutor somebody, I always try to reference what they say back to the slides, right? So they can go back and look at the slides and figure out how can I relate what I learned to the slides, right? So now I wrote an answer down for the first one. So now I want to delete that. I'm going to take a picture. Let's see. Next. I took a picture to my answer, number 1. Can you please check my answer and see where I went wrong? Times you do something and you can't figure out where you went wrong. So this is what we're going to do. We're going to see if it can show where I went wrong. I know I have my chord in there, but let's see if it matters. This image shows your work to find the derivative of the function 3x cubed minus 4x raised to the 5th. To check your answer, let's summarize what you've written. You've applied the chain rule correctly by taking the derivative of the outside function and multiplying it by the derivative of the inside function. So it used your terminology. That's really cool. As it's going, it's using your terminology that you like or that you're familiar with and applying it. Okay. The outside of the function, the derivative is 3x, yep. Your math on the derivative of the function is correct. The derivative should be 4x squared minus 20 times 3x squared minus 4x raised to the 4th. Okay, you've applied the chain rule perfectly, so well done. Interesting. That is not what I write. So the derivative of the function using the chain rule should be 5 times 3x cubed minus 4x times 9x. I did not write that. Interesting. That is not what I wrote. Is not what I wrote. And so then if you say that's not what you wrote, you kind of have to just tell them what you wrote. The first section, I got 5 times 3x cubed minus 4 times 9x squared. So these are common mistakes that I wrote that people do. Sometimes they forget to write the exponents. Sometimes they forget to write the inside of the exponent and take it proper, and then take the derivative properly. And then he said, let's clarify and find where the mistake happened. All right. So I didn't differentiate it correctly. As it said here, it definitely should be 5x or 5 times 3x cubed minus 4x raised to the 4th times the derivative of the inside, which is 9x minus 4/5. Multiplying it by 5, 3x squared minus 4x, and by 9x squared, not just 9x squared, the term 9x squared minus 4 is the complete derivative of the inside function. And it wrote it. And you can't forget the exponents on there. And as you can see, even if it wasn't correct on exactly what you did wrong, you more likely should be able to follow the steps. And if you can't, just keep asking. where you went wrong, or just say, hey, maybe sometimes it's better just to start over, right? All right, and then take it down step by step. But overall, it did a pretty good job of trying to figure out what to do. And now let's move on to the derivative of natural logs. Now, thank you. Now can we go over derivative rules? What if you don't know what natural logs for ln? Those are natural logs, so let's see if it knows that. Certainly, the natural logarithm, denoted as ln of x, has some specific rules when it comes down to differentiation. This is the first GPT I've noticed, this math one, how it's not very good with the code, the latex code, that ln, that parentheses backslash ln of x should look nice and smoothly as it did right in the first sentence. So it says the natural log of x is equal to 1 over x, which is good when you're dealing with more complex expression inside the logarithms, such as natural log of x, where g of x is a function of x. Okay, example. Natural log of x squared minus 5x is 1 over x squared minus 5x. So then, so it's 1 over the inside. So for natural logs, it is always 1 over the inside of the ln function times the derivative of the inside of the function. Sometimes it could be mathy, the mathy words, and I know a lot of you aren't math people, and that's okay. So using those steps of trying to find the natural log is all right. Remember that. That's okay. So ask it. That's the rules on there, and it says exactly when dealing with natural logs, the function of the derivative is indeed 1 over the inside of the ln function. Now, can you show me the steps for solving number 2 on the uploaded document? Now, let's see how it goes. Absolutely. Let's work through the problem number 2 from your uploaded document, which is the derivative of the natural log of x squared minus 5x. So here are some steps we follow applying the derivative rule for the natural logs combined. Identify the inner function, x squared minus 5x. Differentiate the inner function with respect to x. So that's 2x minus 5. Cool. Apply the natural log derivative, which is 1 over that, times the derivative. Cool. Substitute u of x back into the equation. Excellent. The inner function when applying the chain rule to the natural logarithm. Key, it's telling you one thing I like, and I would say the same thing if I was a tutor, things that people mess up on. Remember to multiply the derivative of the inner function when applying the chain rule to the natural logarithm. That is very cool. Hey, don't forget, people mess up on this. Don't forget to do that. Cool. Would you like to go through another example, or is there anything else you'd like to explore? No, let's move on. Now let's move on to number 3. I am completely confused on what to do. A lot of times in math or in any subject, some professors get upset because they're just like, well, what questions do you have? And sometimes kids and students are just like, I don't fucking know. I don't even know where to start. All this shit's confusing. So let's see how ChatGPT does. When differentiating an exponential function where the base is e and the exponent of a function of x, we use the chain rule. Okay, so everything kind of follows that first chain rule. And let's see, identify the inner function. So we have the inner function. Differentiate the inner function with respect to x. All right, 2x squared minus 7x. So that has to be 4x minus 7. We've done that. We've done that in the past 2 videos. Easy. Apply the derivative rule for the e to the power of function, which tells us that the derivative of e of u of x is e of u of x times, that's the derivative of that function. So it's e raised to that same power times the derivative of that exponent. Okay, put it all together, multiply e to the u by u of x to get the derivative of h of x. So it is the e raised to the exponent function times the derivative of the exponent. Is that what it is? Yes, that is correct. When differentiating an exponential function where e is raised to the power, that is a function of x, the derivative is the exponential function times the derivative of the exponent. In the formula terms, the derivative is that. To keep your specific function h of x. See, a lot of times the formula terms doesn't make sense. So let's say now, can you summarize the 3 rules we went over by not using the formula terms? That makes it more confusing for me. Yeah, it's understandable. A lot of people, am I a formula guy? Yeah, but I'm a math guy. And that's all right. I've understood that not everybody, majority of the people aren't like me and enjoy and can see it by the formula. So now that we've gone through them all, now can you put them in one area when it's not in formula terms? When you have a complicated expression, think of it as a multi-layered cake. To find out how much cake is left after some is eaten, i.e. the derivative, you first look at the top layer, outer function, and see how quickly it's disappearing. And then you consider how fast the next layer underneath is being eaten. Multiply these rates together, and you'll know how fast the whole cake is vanishing. If you're looking at the natural log of something more than just x, like ln of something, imagine it's a selfie on your phone. To understand how the image changes when you zoom in or zoom out, first think about how clear the image is. That's 1 over something part. Then consider how the zoom itself changes as a pinch, the derivative of that something. Combine these two to see how your selfie changes overall. Interesting way of looking at it. Love that. Exponential rule. When dealing with e raised to some power, think of it as a growing plant. The rate at which the plant grows, i.e. the derivative, is the current height of the plant, that's the e to the power, times how fast the accelerator is, the exponent, is being expressed, the derivative of the exponent. In essence, for each of these rules, you're combining the rate of change of one part with the current state and rate of change of another part to find its overall rate with the expression. Cool. That was way, and then for some reason, I kind of want to see how, thank you, perfect. Now can you change the summarization slightly by showing when and what to take a derivative of. So now it's like, all right, we did that. It doesn't say, hey, outside function, take the derivative of the outer. Now I take a derivative of the inner. So you've got a function tucked inside of another. Start with the other function, but don't touch the inside part yet. Just pretend it's simple x and take the derivative as usual. Now separate that. Separately, take the derivative of the inside function. Perfect. That's a 2-step, first recognize. All right. Now, can you put an example within each of the 3 rules. Actually, let's lace up these rules. Chain rule example, and then it's going through each example. Top paint layer, which is just something to the 4th power, and now it's kind of walking you through it. You've got the first one, as we went over, that's just explaining what the rules are and when they're ever going to be used. Now we have a little bit more. The next one is a little bit more of, hey, when do I take these derivatives, which I liked. And now the last one is an example. And you can keep these, copy and paste these in a Word document so you can reference them somewhere and study from them. Because now what I like to do is, perfect. Now, can you please provide me with 6 examples on when to use these rules with the same level of difficulty? I want to practice them. Do not give me the answers until I have worked them through. Boom. You want to help yourself, right? The only way to do that is to practice. So what's great is it's now going to provide you with questions and answers that you can practice on your own. And that is something that the textbook can only has a finite, and it doesn't show you step by step. The professor doesn't have enough time to sit there and just boom, boom, bombard you. A tutor in a 1-hour session can't go over a lot of them. But as a tutor, now if you're tutoring somebody, utilize this so you can provide extra work or extra things that the student can do to help improve their grade. I think that's awesome. Okay, everybody, that's our part 2 of our calculus series. Stay tuned for part 3, where I'm sure we're going to tackle, let's see, what are we going to tackle here for part 3? Oh, we're going to tackle second derivatives and a little optimization. So that should be a lot of fun. Thanks again. Comment down below, like, subscribe, comment down below if you enjoyed it, or if you have a problem that you want to cover, or if you have a topic you want to cover. Hit me up on X at @TheTutorJustin. I hope everyone has a great day. Peace.